Hello viewers, you're welcome back. So in this video, we'll be looking at the number of solutions of a linear system in two variables. So if you have a linear system could have one solution, it could have more than one solution. And it's possible for a linear system not to have a solution. So like for example, if you have something like this, let me just give you, let's say this is a linear system. Because this is a two lines, you can see they intersect only at one point. So it means the system has only one solution. But if you look at this, the second one, here you see that you have only one line. It means the two lines are on the same. So it means you're going to have infinitely many solutions. So for example, if you have this is one line and you have another line on it, it means they will intersect at infinitely many points. But if you look at this one, the third one here, there is no solution. Why? Because you have two parallel lines which will never meet. They will never intersect. So it means there is no solution. So for example, if you're trying to solve a linear system and you get something like 0 equals to 9, this statement is a false statement. So it means there is no solution. If you get something like 3 equals to 3, or 0 is equals to 0, or 1 is equals to 1, this is always true. So it means such kind of system, you're going to get infinitely many solutions. And if you get maybe x is equals to 2, y equals to 5, these are just 1 point. This is just 1 point, so you have one solution. So now let's talk about consistent system versus inconsistent system. So what is a consistent system? A consistent system of equation has at least one solution. So what do you mean at least one solution? It means one or more, right? So if you have a system that has one solution or more than one, then we say the system is what? Is consistent. But if there is no solution, then we say it is what? Inconsistent. So inconsistent means no solution. Simple as that. All right. So let me give you another explanation to this. Now look at these two lines. So let's say this line here, the red one, let's call it the line M1, Y1. So let's say it is M1 X plus what? B1, right? And the second line, Y2, let's call it Y2. So this line, call it Y2, which is M2, B2. So you see, since this line intersects at one point, what does that mean? It means it has only one solution. As you can see, it has only one solution. So it means it is consistent. So we say it is consistent, but not just consistent, it is what? Independent. And here, one thing you can see is that since these two lines intersect one another, what can we see? We can see that what? The slope M1 is not the same thing as what? M1 is not the same thing as M2. This is obvious. The slopes are never the same. Now, also, if you look at the intercepts, what is the intercept? The one intercept means B1 and B2. So it's fine. B1 and B2, you can see in this case, they are not the same, right? What is B1? Remember, if this is a line, B1 is this, the y-intercept here, right? So this is our what? This is our B1. This is our B1 because B1 represents the y-intercept. So this is B1, right? But where is B2? B2 represents what? the y-intercept, which is B2. So you can see in this case, B1 is not equals to B2, right? So it means the only condition you have for one solution is that the slope should not be the same. But because this is important, because it's possible for the y-intercept to be the same. For example, if you have a line, if you have, let's say you have the two lines to be this one. If you draw something like this, let's say this is the first line, right? And let's say this is another line. So let's call this one line 1 and line 2. So you see this line, they meet only at this point. So you see they have one solution and they also have what? The same y-intercept. And this has only one solution. But if you look at in this case, let me explain what I'm saying here with a better diagram. So what I'm saying is this, you have this line, and let this become the red one. The red one, let's say it's this, and let the blue one be this one. So if you look at this one here, what you are going to have is that this line is, call it your, no, call this one your y1, which is m1 plus what? b1. Don't forget that this one is y2, which is just m2x plus what? b2. So here also is the same. Y2 is m2x plus what? b2. So if you look here, you see here they are intersecting at one point. So it means it's possible for b1 to be equals to what? b2. But the slopes are not the same, but m1 is not equals to m2. But if you look at this one, if you look at this one here, this is going to be our b1, and this is going to be b2, right? So you see that here, b1 is not equals to b2, so m1 also is not equals to what? m2. So it means it's possible, in the case of having one solution, it's possible for the y-intercept to be what? To be the same or not to be the same. So we have these two conditions here, this one. So it means what is really important is not the y-intercept, but the what? The slope. So that is why we pick only this one. So the slope must not be the same, right? But if you come to this one, in this case where you have consistent or what? Dependent. This happens when you have infinitely many solutions. So if you have these two lines, you can see that these two lines, they are what? They are on the same line. So it means your y2 is what? Don't forget, mx plus what? b2. And the y1, which is the red one, is just m1x plus what? b1. So you can see that because they are on the same line, you will see that the slope must be the same. So m1 is equals to what? m2. And not just that, the y-intercept also must be what? Must be the same. We have this one. Now, in this case where you have parallel, so let's say the red one is y2, which is m2x. No, the red one, it's y1. So y1, m1x, which is the slope of the line. Remember here, we're using the slope intercept form. And y2 is what? Is m2x plus b2. So if you look at in this case, you see that the slope will never be the same, right? It is clear. You can see from there that the slope, because, okay, the slope will always be the same. I mean, because they are on the same, they are parallel, yes? So parallel lines have the same slope. So you see that M1 is equals to what? M2. But what can never happen is this one, because this point is our what? B1, which is our y-intercept. And this point is what? Is the B2, which is the y-intercept of the blue line. And now you can see that what we can say is that another condition that has to be satisfied is that B1 is not equals to what? B2. So these conditions are very important. So for consistent or independent, we have this one. The slope will not be the same. That is the only condition you need. For consistent or dependent, you have infinitely. You have this condition, M1 is equals to M2, and B1 is equals to B2. And for inconsistent, which will mean no solution, we have M1 is equals to M2, B1 is not equals to B2. Now, let's see how we can use these conditions to solve problems. So this is very important because this will help us in determine whether a system is okay. Now let's look at this one. Let's just start from here. Here we're just asked to determine whether the following system are consistent. So let's see now whether they are consistent, inconsistent, dependent, or independent. So two ways to do that is just try to solve. Yeah, just try to solve. So if you try to solve this now using any method you like, if we want to use any method we like here, we can try to use either elimination or substitution. So let's use elimination. We can use elimination by multiplying this by 2 and maybe multiplying, let's say by 3 and multiplying this by -2. It's fine. So that this will become 9x, right? So this will become 9x. Okay, this is lagging. Let's see how to do this. So if you multiply this by, we're multiplying this by 2. We can multiply this by 2. We can multiply this by -3. So that this now becomes what? 6x plus what? 12y. It's equals to 22. And here now we can multiply this by this. So this becomes -6 plus, no, it's going to be -12 now. This is also going to be -12y. And this is going to be -27. So you can see we just multiply by -3, the second equation. And this is what we get. Now, if you try to eliminate, remember, you can add these two equations. This will become 0. And this will become also +0. And this will become what? 22 minus 25. This is going to be -5, right? So we're going to have 0, it's equals to -5. So you can see that this statement is false. And so if this statement is false, you have something like this. This is just going to fall under which category? There is no solution. This is this one. Yeah. So there is no solution, or we can use this one, which is the same. So now we say these solutions are what? So here we can say there is no what? We can say there is no solution, or which also we can say they are what? They are what? Dependent or independent. As you can see here, when you have this situation, we say there are what? Inconsistent. So inconsistent. That is what we can say. And now, if you look in terms of slope, you can see that if you want to use the slope argument, you can see that if we're in this case, remember we're in this case, the slope will have to be the same and the y-intercept will not be the same. You can also use that to check. Now, if you look at this one, let's say you try to find the slope of this line. What will be the slope of this line? If you rewrite this one, this is 6y. 6y, it's equals towards minus 3x plus 11. You define that y is, you divide both sides by 6 plus what? 11 over 6, right? So if you look at this line, you will see that your first slope, m1, is just what? Minus 3 over 6, which is minus half, right? Now, also, if you go with this line, you will see that this line, you can write it 4y is what? Is minus 2x plus what? 9. So y is going to be minus 2 over 4x plus what? 9 over 4, right? So you see that from here also, you will see that your M2 is minus 2 over 4, which is minus half, right? And what is your B2, which is the slope? The slope is 9 over 4. So what is the slope here? The slope here, B1, not the slope, I mean the y-intercept is 11 over 6, right? So if you compare this, what do you see? You will see that what? M1 is the same thing as what? M2. Where is M1? It's minus half. M2 is minus half. But B1 is not the same thing as B2. So you see, that is why the system falls under what? Inconsistent, no solution. The lines are parallel. All right, so let's look at the B question. Now, if you look at B, also, what do you do? Just try to solve. If you try to solve, you will see. So let's try to solve this one. So here we can use any method. Let's use substitution here. Let's call this one. So you can see from 1, you can see x is what? Is 2 plus what? 2y. So let's substitute x in what? In equation 2. So this will be 3 into 2 plus 2y minus 6y is equals to 6. So this will give us 6 plus what? 6y minus 6y is equals to 6. So here, as you can see now, what we can do is that 6y will cancel 6y. This will go with this. So we have 6 is equals to 6. Right. Now, this is always true. And anytime you have this, always you have something like this, it means we are falling under which category? I think I explained this earlier also. So for example, you have 3 equals to 0. So it means you will have infinitely many solutions. And it's going to be consistent because we said a consistent system has one or more solution. So, which is what we have here. We said it's going to be a consistent, dependent, infinite solution. So the conclusion is going to be this one. It's going to be consistent. It is consistent. Why? Because it's going to have more than one solution. It's consistent. It is dependent. And it has infinitely many solutions. Now, why is it consistent? Because it has more than one solution. Because this is always true. Always true means you are going to have many solutions. And that is why you have infinitely many solutions. It's dependent. Now, when you have something like this, how do you write the solution? You see, in this case, we say there is no solution. So you are done. You don't have to write anything. But if you have infinitely many solutions, then you have to find a way to represent the solution. So let's do that now, which we call or another way in this one, we can say the solution set is actually empty because there is no solution. But here, the solution set is not empty. So how do you write the solution? It's very easy. You can already here, let's do it from here. Remember we said x is what? X is 2 plus what? 2y. So what we can do is we can write, we can say let's our y, we can choose y to be equals to k. But what is k? K means any real number. So if y is equals to k, where k is any real number, what does that mean? It means x is just going to be 2 plus what? 2k. Remember, k is any real number. So remember, if you want to write a solution, our solution usually is supposed to be in the form of x comma y, right? This is how the solution of any linear system in 2 dimensions should be in 2 variables. So now, this is going to be x. Once you let y to be k, so our y is going to be k. Our x is going to be 2 plus what? 2k, comma. And what is this k? This k is any real number. So this is our solution set. Now, this is our solution set. So what does that mean? It means if you take k to be any real number, let me give you an example. An example, if you take k to be, let's say 0, if you take k to be 0, it means one of the solution will be 2 plus, if k is 0, you're going to have 2 comma 0. This is going to be a solution of the system. Now, how do you check? You can check, substitute 2 and 0 into this equation 1. It will be a solution because x will be 2, y will be 0. It will solve the system. Now, you can take another k. You can take k to be, remember, k is any number. For example, if you take k to be 1, if you take k to be 1, what will be the solution? You're going to have 2 plus 2, so it's going to be 4 comma 1. This is also a solution. So you can generate many, many solutions. Is that okay? Now, let me show you another way to write this solution here. So it depends. This is one way to do it. We will see another way. Here we are choosing y to be k. We can also choose x to be k, and we write y in terms of k. So we'll see that in other question. So for now, let's move. Now let's go to this one, C. If you look at C, also we can try to what? We can try to solve directly and then look at trying to eliminate. Let's call this one equation 1, equation 2. So we can multiply this by let's say minus 3. It's fine. So this will become 9x minus 9x plus what? Minus 9x minus 6y, it's equals to 12. And this is still 9x plus 6y equals to what? Minus 8. So what we can do is that we can add now. If you try to add these two, what are we going to get? Remember, we're using elimination method. So if we try to eliminate this by adding, this and this will go. This is 0. This is also 0. And this is going to be 4, right? So what do we have? We have 0, it's equals to 4. This is also false. Always false. So what does that mean? This means there is no what? No solution. And then we can say the system is what? Is inconsistent. And we're done. So here, also, we can try to eliminate. And we can easily achieve that by multiplying this by, let's say, minus 4. So that this will be 8x minus 4y, it's equals to 16. If you multiply by minus 4, this will be minus 8x plus 4y, it's equals to minus what? Minus 16. We can add, if you add, this is 0 plus 0 equals to what? 0. So we have 0, it's equals to 0. Yes. And this is always what's always true. So if you have always true, it means that what? You will have infinitely many solutions. Now, not just infinitely many solutions, your system will be what? Your system will be consistent, surely, because remember we said consistent means that you have more than one solution, and it's just going to be what? Dependent. So dependent system, okay? So remember, if you have one solution is independent, okay? So if there is no solution, then it's also independent because there is no solution. But here you have infinitely many solutions. So this is the only place where we talk about dependence. So here, you see there is no solution, right? No solution means that the system is what? Inconsistent. Yeah. So in other words, you can even say they are independent. There's no problem. All right. Now, I think that will be enough for this video right now. All right. So in the next video, we will look at some brief old exam questions. Now, before we finish here, let's try to write the solution set here. Let's try to write the solution set. So for question number C, we can say the solution set is what? Is empty, right? Because it's false, no solution. Now for D, we have infinitely many solutions, and we're going to treat it just the way we solved, I think, example B. So how do we do that? Let me try to get the solution here. Now, anytime you have infinitely many solutions, all you need to do, just solve for one variable. So for example, now, from where? You see from equation 2, from equation 2, you can see that you can solve for y. Y is easily equals to what? 2x plus what? No, 2x minus 4, right? So it means that your y, and that is why we say they are dependent, because if I want to get y now, it depends on what is x. So we can say let x be equals to k. But what is k? K is any real number. So it simply means that our y is going to be 2k minus 4. So it means our solution, what is the solution? Our xy is going to be what? You just replace x with k. So this is going to be k. And what is y? Y is 2k minus 4. Then you put a set. But what is k? K is any r. So this is one way to rewrite the solution. So here you can see that what? Our y depends on our what? On our x. Now, this is one way. Or, if you don't like this one, so from equation 2, instead of making y the subject, you can still make x the subject. Or, from where? From equation what? From equation 2, you will see that we can solve for x. You see x is going to be y plus 4 divided by 2. You can see that? So, and you can let what? You can let y to be k. You can let y to be k. You can let y so now we can say let our y be equals to k in R, right? So if you do that now, you will have x is going to be k plus 4 over 2. So our solution set, remember it's supposed to be x comma y in a way, but this is going to be x is k plus 4 over 2, then y is what? Remember, y is what you set to be k, so y will just be k. And then k is in what? In R. All right, so this is another way to write these two sets of these two solutions are the same. All right, so in the next video, we'll solve a few old exam questions. If you have any comments, you just put it in the comment section. Thank you for watching.